Okay, now we're going to deal with the mean value theorem, and just as it was with Rolle's theorem, your function should be continuous on the closed interval and differentiable on the open interval. And if it meets that criteria, then your mean value theorem states that there's at least one number C such that the derivative at this value C would be equal to f of b minus f of a divided by b minus a. And of course the b and the a are in reference to the numbers that are being used here for the closed interval and the open interval. But somewhere in this interval there's a number c so that the value of the derivative of that number is equal to this. Now, what that means, of course, when you have a picture to look at, it'll make a little bit more sense to you. Here's what you're dealing with. Okay, so let's say that the part that we're seeing here that's in blue, this is our function, okay? And you're looking at this from x equal a to x equal b. So this is the portion of the function we're looking at over the interval that's being described. Okay, so this point would be referred to as A. Of course, that would be the x value. So the y value is f of A. Of course, here your x value is B, and then this y value would be referred to as f of B. Okay, so we have a secant line, you know, that's cutting your function that's going through these 2 points. Okay, so your C, see here, is falling in between your A and your B. So what this theorem states is what I've explained here in this little paragraph. It says the theorem guarantees the existence of a tangent line that is parallel to the secant line through the points A, f of A, and B, f of B. All right, so it says that the tangent line would have to be parallel to the secant line, okay? And if you think back, since we're talking about, of course, derivative, you know, always has to do with the slope of the tangent line. And if you look back here at your mean value theorem, this portion right here is actually just your slope formula. Because, see, this would represent your y value of this point. This is the y value of this point, and you're subtracting those y's. And of course, just A and B are your x values. So this is subtracting y's over subtracting your x's. So this portion of it represents the slope of this secant line. So we know there's a C value in here. So at that particular point, the tangent line at that point would end up being parallel to this secant line. So I mean, that's why you can state that your derivative, because this would be tangent, your derivative at C would have to be equal to this. Of course, we know that parallel lines have to have the same slope, therefore that's why we can state that they are equal to each other. Okay, so our first example, of course, it tells you to apply your mean value theorem and to find all values of C. All right. So, first of all, just kind of taking a couple of steps here to find the information that we're going to need. You're going to need f of A and f of B. Of course, in the interval that they give you, this is going to be your A, this is going to be your B. So, first of all, let's just calculate f of 1. Now, these values are just being plugged into the original function. So that would be 5 minus 4 over 1. So that'll just give us 1. And then f of 4, so that would be 5 minus 4 over 4. So that will give us a value of 4. All right, so we'll need that, or those two numbers, you know, to take care of what we need here in the numerator. Now, I'm setting this equal to the derivative. So next thing I'm going to do is find the derivative. Now, I'm going to actually rewrite the function. Let me just come back up here. And I'm going to rewrite this before I take the derivative. Because if I rewrite the 4 divided by x as x to the negative 1, then I'll avoid having to do the quotient rule. All right, so my derivative, of course the derivative of 5 would just be 0. And now applying your power rule, that would give you 4 times x to 1 less power. Rewriting this so that you have a positive exponent, then that would just give you 4 over x squared. Okay, so again, going back here to our rule, I can state that my derivative is equal to this. So I found my derivative to be 4 over x squared. And that would be equal to f of b, so that would be the 4. Here, let me just write it out. Let's say that would be f of 4 minus f of 1 over 4 minus 1. So f of 4 actually was 4, and f of 1 actually happened to be 1. So what I have at this point is that 4 over x squared would just be equal to 1. Now let's solve this equation. So I would just cross multiply. So therefore you would have x squared is equal to 4. So x would be equal to plus or minus 2. Now I know, of course, in the formula here for your mean value theorem, it states the derivative at c, but of course c is what we're trying to figure out. Of course, c is just representing an x value, so we're just actually working out this in terms of x. But, you know, if you're asked what is the c value, your c would actually be just the positive 2. And the reason why it would not include the negative 2 is your interval was just from 1 to 4, and negative 2 would not be in your interval. So I'm just going to say negative 2 is not in the interval. I mean, it's not that you would have to put that statement, say, on test. You would just need to make sure that you indicated that only C would be positive 2. You would just need to know to leave that out because it's not in the interval. Okay, now just if you wanted to look at it, and what I did is actually just I took a picture of what was in the textbook for this example. This is the function that we were looking at, and you were told the interval was from 1 to 4. So here's x equal 1, which happens to be the point 1, 1. Of course, that's why we found f of 1 to be equal to 1. And then here's x equal 4, which would be the end of that interval, and that would actually be located at 4, 4. So again, that's why f of 4 was 4. So in doing the calculations on this half, of course, this is using your slope formula here. We found that the slope was 1. So that just meant this secant line that goes through these 2 points, this secant line would have to have a slope of positive 1. And what you have done is you have found the point that's between these 2 points that would have a tangent line of 1. So if your secant line has a slope of 1, then you're looking for this, or you're looking for the point that would have a tangent line that would also have a slope of 1. And of course, that's what you located when we said, okay, this C value, or this X that's between 1 and 4 would have to occur at 2. Okay, here's another example. All right, again, first thing that I'm going to do is just find the f of 1/2 and the f of 2, because remember, this is going to be your A and this is going to be your B. Okay, so f of 1/2. Of course, when you're doing this, you're plugging it back into the original. So you'd have 1/2 plus 1 divided by 1/2. That's going to simplify to be 3. And then f of 2 So we'd have 2 plus 1 divided by 2, so that's going to give us 3 over 2. Okay, we do need our derivative. Now, finding the derivative this time, you are going to need to use your quotient rule. So we'll have low d high minus high d low over low low. Of course, x times 1 is just x. Now, I can ignore this times 1, but I do need to distribute the minus sign here. And I'm sorry, this right here is supposed to be x plus 1. Make sure you correct that. So that means this needs to be a minus right here. So that would just simplify to be negative 1 over x squared. Okay, so that means that my derivative would need to be equal to f of 2 minus f of 1/2 divided by 2 minus 1/2. Okay, so if you do the f of 2 minus the f of 1, so that would be the 3/2 minus the 3, then that's going to be a negative 3/2. And then 2 minus 1/2 is going to be a positive 3/2. Okay, so that'll give us just negative 1. Again, just cross multiply. So we're going to end up with x squared is equal to 1. So x is equal to plus or minus 1. So it's possible, you know, that both of these, I mean, you can have more than one c value in your interval that would have a tangent line with the slope, with the same slope as the secant line. That can occur at more than one point, you know, just depending on what your graph looks like. But in this case, we're only looking at this, you know, between 1/2 and 2. Therefore, the negative 1 would not actually be the c value that you're looking for here. It would just be the positive 1. Of course, that's, you know, same thing that we saw happen on the previous example. Your answer is only going to be what's within your interval.